Hello friends, today it's about Higgs field. So it must be really interesting to know, like we are made up of matter, we're made up of atoms, and these atoms have weight. So we have weight, right? Like I have maybe 100 kilos and you may have certain weight. But where do we get this weight from? How does these particles or how does these atoms gain mass? That's really interesting to know. Okay, and today's video I'll try to keep it as simple as possible. So before starting, I would just want to say that that we know from high school that science that uh, atoms are made up of nucleus, and then here is this electrons which rotate around this nucleus. Okay, but in particle physics, as we know that this nucleus itself can be divided into many parts. Like this nucleus has protons and neutrons, and these protons and neutrons are yet made out of some fundamental particles. Like for example, if you take this as photon, this as neutron, and these photons and neutrons are made up of some more elementary particles which is called as quarks. Okay, and even the neutron is made up of three quarks, and then you have these electrons which is I mean electron is made up of electron. There is nothing divisible in electron. Electron is a fundamental particle like quarks, but nucleus is not a fundamental particle. Okay, nucleus is set of protons and protons is a set of quarks. So quark is the elementary particle here. And then you have something called as photon, which is the light you see from the sun, or the light or the x-ray, or you can talk it of ultraviolet rays, you can have infrared, the heat that you feel on your skin, everything, radio waves, mobile wave, or the microwaves, everything is made up of these photons. Okay, so we need to know that so I can just write it down. So there is this quarks, there is this electron, there is this photon. Okay, so today we'll discuss only about these three particles. Okay, so if I were to say this photons has no mass. Okay, this photons is responsible for the light, as I said earlier, and these electrons and quarks which makes up the atom, it has certain mass. Okay, it has certain mass. Now the question is, how does electron and quark get their mass? It's really interesting, and here I would say that it's a little difficult to imagine, but I would try to keep it as simple as possible. Okay, so before starting, I want to say what is this field. Okay, so field means it is some kind of an area or some kind of space around you, to which you can assign certain value. For example, if I were to take the temperature, I can say the temperature here is this much, the temperature here is this much, here the temperature is this much. So in what I'm doing is I'm giving certain properties to this space, and that we call as field. Okay, so in this case it would be a temperature field where I give different temperatures to different points. So like that, there are like many other fields in physics. Okay, so I will explain that in detail later. So now just you have this in mind. So let's start with the what we can imagine. Okay, so imagine this is a well, or this is some kind of a trough between two mountains, maybe you can take it like that. And if I were to draw a vertical axis here, this vertical axis represents energy. Okay, so the minimum energy, so if I tell you where is the minimum energy state for this well, it is here. If you want to stay here, you don't need any energy. Okay, so this is the minimum energy state. If you want to move up this well, if you want to climb up this well, you need certain energy, and that energy is equal to this. Okay, the craziest thing about quantum mechanics is that what we call as light, or example this photon, is everywhere. Okay, but it is not, but it is not as a particle. Okay, it's just there at rest. When you try to give some energy to this field, to this well, you move up here. As you move up, you form a photon. So wait, let me try to explain this in a simpler way. So let's say this is this field, as I told you, the space around you, okay, and you have some electron, okay. So electron is the one which gives energy to this field to create light. So always whenever you talk about light, is some kind of electron moving. So the sun, if you see how sun is generating light, it is basically at very high temperature, the electrons are moving and it creates light. So okay, so you have this electron, you take it in your hand and you try to move it up and down, or whichever way you want, okay. When you try to move this electron, you're giving some energy to this, and this energy, this goes like this, and when it goes like this, you form photons. So in this space, when you disturb this electron, you form a particle here, you form a particle here, you form a particle here, you form a particle here. So this is how the light propagates. So basically, by moving this electron, you are kind of going up the well, and wherever you are forming, wherever you are exciting this state, you have the photons. But if you don't excite here, you don't have any photon here, because at this point you are at rest, so there is no photon here. Only when you try to give some energy through electron, you have certain light particles here. So this can be radio waves, this can be microwaves used by mobile phone, it can be anything, okay. So that's how I would explain. So this is an excellent idea for representing a electromagnetic field. Just telling you the name. So whenever you have an excitation in the electromagnetic field, you have light, okay. That's the way how you can understand this. Now let's talk about Higgs field. So what is this Higgs field? So in this what you see here, this is called as a symmetric thing, okay. So where your minimum energy state is at this point. Now when you talk about Higgs field, the same field that you have here, it is something like this, okay, like a Mexican hat, I would say. And your energy, again same, this is your center, okay. Now if you see, the minimum energy point is not here. So if your particle is here, it's not stable, it's going to fall down here. So the minimum energy state, where is the minimum energy state, is here. Now the minimum energy state for some kind of, now we talk about photon, now this is about the Higgs field, okay. So this is the Higgs particle. Now the electromagnetic field has photon, so Higgs field has Higgs particle, okay, it's called as Higgs boson or something. So you have this Higgs particle here at the rest point, but you see a difference. In this, it was at the center. In this, it is not in the center. It is having some offset from the center. So it is this offset from the center which gives it some kind of, I would say, which gives it some kind of energy, extra strength to this Higgs particle, okay. So I'll tell you what is it later. And it also means that these particles are infinite. There are a lot of particles like this, you can take whenever you want and you can put it back, nothing happens here, okay. This is the Higgs field. Now okay, so let's talk about how electrons and quarks gain mass through Higgs field. So what electrons and quarks do is, they kind of interact with this field, and when they interact with this field, there's already some kind of there's some kind of strength here in this field. So whenever it interacts, it gains some mass, okay. So I'll explain that. So you have this electron which is going in this direction. So electron has some property, you call it as left-handed and right-handed electron. So what it means is, when the electron is moving like this in straight direction, it curls to the right, which means the electron is rotating around its axis. This is the left-handed, and let's say this is the electron. There's another form which is called as right-handed. So electron has two orientations, this is left and right. So when it moves forward, it can rotate like this, it can rotate like this in opposite directions, okay. So let's, for simplicity, imagine electron has certain quality or certain property, okay. It's called as a quantum property. It has certain property. Let's say it has a certain property of color. Left-handed has a color, right-handed has no color. Okay, in real it's not called color, it's called something else, but I am trying to make it simpler. Okay, so it has some color, it has no color. Okay, so this electron, when it moves from left-handed position, like it moves from this to this, so this has color, this has no color. So according to conservation, you have to throw this color out somehow. Okay, you have to throw this color out, okay, when you are moving from left to right. And similarly, when you are moving from right to left, you have to get this color in. Similarly, when you go from left to right, you throw this color out. But how does the electron manages to throw the color out? So what it means is there must be some other particle which has color in it. So electron gets that color, throws that color, gets that color, throw that color. And that's how this becomes left, right, left, right. So the particle which has this color is the Higgs particle here. So Higgs particle has this property of color which electron gains and throws it back. And the reason that this Higgs particle is a little offset, so this has some extra field. I can just put it, because it's here, it has some extra mass. Okay, so this has some mass, this Higgs particle. So the electrons, when they move from right to left, left to right, right to left, they gain their mass. The same way, if you talk about the quark, they move from left to right, right to left, left to right. So even quark will throw away color, but what is the color? Color is certain property, and what particle has that property is the Higgs particle. So there's like infinite amount of Higgs particle here, so you can take and throw away how much ever you want. And this is how quarks gain mass. Okay, now you can say the quark is much more heavier than electron. Quark is much more heavier than electron. How is it? It's because the quark moves from left to right more number of times than electrons. That's why quark is like having a lot of is moving front and back, moving from left to right. In a second it goes like 10 times, just for example, and the electron is just going 2 times. So the more it goes from left to right, the more it interacts with this Higgs field, the more it takes and throws this Higgs particle away, and the more it has this the mass to it. Now you can ask the another question: why does this photon doesn't have any mass? So imagine this electron is moving. Now the photon, in this case, it's moving at speed of light, and that's why we call it speed of light. So the photon is moving at a really high speed. Okay, and this photon doesn't have this this left and right property. Only because electron has left and right property, it gains mass, and this photon is moving at a very high speed, which means that the time is still. There is no time for photon. It's just frozen. So that's why this photon doesn't interact with this Higgs field. That's why the photon doesn't have mass, and thank God it doesn't have mass, because if it had mass, then the light which you see from the sun would have mass. Okay, so imagine, it's a crazy world to live in. So this is the best possible way of explaining this Higgs field, how electrons and quarks gain their mass, which makes up the atom, which makes up the human body, which makes up the universe, which makes everything. And we gain our mass from this Higgs field. Thank you.